All right, hi everyone. We're going to go over the last formula you'll need to know from this set of notes. So today we're going to talk about the compound interest formula. So this allows interest to be on the principal and on previously earned interest. And this is how a bank would actually look at how you're getting interest in a bank account. So some of the formula is exactly the same as you've seen before. A is going to be that final amount. P is going to be the initial amount. R is going to be the interest rate. Make sure you make it a decimal. N is the number of times something is compounded. We'll talk about what that means in a second, which basically means how often the interest is taken. And then T is time. Now for this particular formula, it's in years because N is the number of time compounded per 1 yearly cycle, because that's how we talk about interest. Now, some frequently used words for compounded would be like compounded yearly would be 1, compounded monthly would be 12, compounded daily would be 365. So basically just figuring out how many times something is compounded. Everything else that we learned yesterday is the same. We can just plug in and find the missing variables depending on where it is. We'll use different strategies. So let's jump in. So how long to the nearest tenth of a year will it take $4,000 to grow to $5,600 at 15% annual interest? That's compounded monthly. So the fact that it's saying compounded monthly is what tells me to use this formula that now has that n value in it. So we're taking r over n, and then we're raising it to the nt power. So from here, I'll plug in some stuff that I know. I want to make something grow to $5,600, but it starts at $4,000. 1 plus my interest rate is 15%, and then it's compounded monthly, so the n value is 12. And then we're going to raise it to the 12, and then t is what we don't know. It wants us to know how long has it taken to do this. Now from here, again, remember you can go to Desmos or use your graphing calculator. You could type this in as y equals the first half. You could type this in, y equals 4,000 times 1 plus 0.15 over 12 to the 12. I would type in x in Desmos. And then you're going to look for where the two graphs intersect. Try it out. See what you think. Pause the video for a second. You should get a value of approximately 2.2571389, etc. Now the question says, how long to the nearest tenth of a year? So we're going to answer the question the way the problem is worded. I'm going to write a little sentence. Therefore, okay, it took about 2.3 years for the $4,000 to grow to $5,600. And that's your answer. Okay, so if you're looking for a letter that's in the exponent, you will have to use Desmos or your graphing calculator to find that value for now. Eventually, I will teach you how you can find that without it. So let's try one more. Okay, the next one wants you to find if Sarah took out a $30,000 loan at a 4% interest rate to put a new pool in her backyard. If the interest is compounded quarterly, how much interest will she have paid after 12 years? So let's find out how much money it will have grown to after that value. So we'll use our formula again. We know it's this formula with an R and an N because of the fact that it's talking about compounded quarterly. So let's sub in what we know. We know we have started with a $30,000 loan. 1 plus, we have a 4% interest rate, compounded quarterly, 4 quarters in a dollar, so quarterly is 4. And then we're doing it for 12 years, so it would be 4 times 12. You can put the 48th power there if you want. And then you can go directly to your calculator and type this in. So we would get 48,366 and 78 cents. Now from here, the question asks how much interest she's gained. So remember, this is how much is on the loan, right? She doesn't get all of that in interest. I need to subtract the initial 30,000 to figure out how much interest. So then to answer the question, okay, she will have paid let's see, if I subtract 48,366.78 and I take away the original 30,000, she'll have paid 18,300, wow, I can't write today, sorry about that, guys, $366.78 in interest after 12 years. So compounded interest can work in your favor where you're gaining interest on your interest. It can also work against you if you're accruing interest on your interest over time. And that's what you're going to look at. So for the rest of class today, you're going to finish all of the mixed practice problems down here. And then when you scroll to the bottom, you should be able to check your work. The answers should be there for you. On yours, the answers will populate somewhere down here for you. Okay. And then after that, you're going to go to the exponential modeling homework number 1 and complete all of those problems. Answers again are at the bottom for you. Have a great day. Bye.